Welcome to another coding tutorial, and in today's video we're going to be making a flow field using Perlin Noise. You may have come across beautiful images of flow fields, especially if you're into creative coding because they're just everywhere, but you might not actually understand how they work. So let me first explain how does a flow field work. A flow field is made up of two main components. The first one is a grid of force vectors. Just imagine a grid of arrows that are pointing in different directions. The second component is a particle object or a bunch of particle objects. These particle objects have their own position, their own velocity, and their own acceleration. So they can move around based on the speed and direction that they're traveling. And because they're thrown onto this grid of arrows with directions, they're being guided or influenced by these arrows based on where they are on the grid. And what you see on the images of flow fields are just variations of how these particles are traveling on this grid. So now let's talk about how are these arrows and the directions being generated. Using Perlin Noise, that is. Perlin Noise is a technique used to generate random numbers, but with an organic and smooth-like manner. I have a whole series on Perlin Noise, a coding math video where I go through what is Perlin Noise, how is it generated, and how to use Perlin Noise outputs, as well as coding tutorials that go through 1D, 2D, and 3D noise maps. So I totally recommend you checking those out. To create a flow field, we'll be using a 2D noise map, and we'll map these values to the values of the angle between 0 and 360 to give an arrow its direction. How we're going to approach this is that first we're going to create a field of force vectors or arrows with different directions using Perlin Noise. And then we're going to create a particle class using basic physics engine. And I'm not going to go through every detail of how the physics engine works, but hopefully it gives you enough understanding of how it works and how it's all related. To create a grid of force vectors or arrows, first let's declare three variables: columns, rows, and size. And I'm going to set the size to 50. And then I'm also going to create an array, a 2D array, and I'm going to call it arrows. And then inside the setup function, let's calculate the number of columns, which is width divided by size, and then rows, which is height divided by size. All right, and in the draw function, I'm going to use a nested for loop that loops through the number of columns and the number of rows. And I'm doing this so that I can create a 2D array. I've done this in many of my tutorials, so I will link down some below so that you can check them out if you want a better understanding of how to do this. Inside the outer loop, first we're going to populate it with empty arrays. Inside the inner loop, what we want to do is we want to populate the arrows to the array. But before we can do that, we need to figure out what kind of information do we want to put inside the arrows to the array. So as I mentioned before, we're going to use the noise map to map the value from 0 to 1 because that is the output of a noise function to the values of the angle, right? And once we have those angles, we want to use the angle to calculate the direction of a force vector. And I've said the word vectors many times, and essentially a vector is an object that can store two values, x component and y component. It is an object that has magnitude and direction, but in our case right now, just imagine that we want to store two values inside one object. First, we're going to declare a variable called angle, and we're going to set it equal to a noise function, a 2D noise map. So we need to put in two arguments. So I'm going to put in x off and y off. So let's also declare x off equals to 0 and y off equals to 0. We want to map this value, right, from 0 to 1 to, actually, what I'm going to do first is that I'm going to not map it to anything yet. And I want to print out the values to show you. So let's first draw a grid. J times size and then size. All right, so we have a grid here. And then I'm going to write out the values of angle here. And I'm going to put it inside the grid. Let's see. All right, so we also want to round it up to just 2 values, and let's put it at the center. Let's try this. So as you can see here, they all have the same values, right? So when we use a noise function, there's only one noise function every time you run your program, meaning that when you put in an argument of the same values, which is 0, 0, it provides you with the same output, which is 0.48 in this case. In order for us to change the values here, what you need to do is that you need to increment the x off and y off, or x offset and y offset values. So first, let's start by setting the x off value to 0 every time it goes through the draw function. And then inside the outer loop, you want to increment it by a certain increment. So I'm going to set another increment value variable here. Let's do 0.1. All right. So you can see that when it goes through the outer loop, right, which is the columns, it changes its values here, right? But now we also have to do the same thing for the rows as well. So what we have to do is that inside the outer loop, first we need to reset the y off value to 0, and then inside the inner loop, we want to increment it by the same increment. All right, so all the values are different. And if you just pick one value here, let's say 0.59, and then you look at the value surrounding this value here, they're closely related. And increment really matters. So let's say that you do 0.01, the values are even going to be closer to each other. So you can see here, they're almost the same, right? These values are random, but they're not so random. With the noise function, you can see that they're still closely related to each other. All right, so once we have this, I'm going to comment the text out. What we want to do is that we don't want the values between 0 and 1. So we first have to map this value from 0 and 1 to what? To 0 and 360, right? Okay, and also don't forget angle mode, degrees. All right, so actually I'm gonna print it out again. All right, so you can see here it's between 0 and 360, right? But the values are quite close to each other, right? What we're going to do now is that we're going to create a grid of force vectors based on these angles that we just generated. And then we're gonna put those values inside our arrows to the array. Arrows of I and j equals to, we can use a method within the vector class called createVector, and that will help us create a vector. And then we need to put in 2 arguments, which are going to be the x and y values that we want that vector to have. To get an x and y value based on the angle that we have generated here, we are essentially doing the same thing as when we want to convert from polar coordinates to Cartesian coordinates. We need to use the concept of trigonometry. So the equation is x equals to r times cosine of angle, and then y equals to r times sine of angle. And in this case, we want the radius to be just 1. We want it to have a magnitude of 1. The x component will be cosine of angle, and then the y component will be sine of angle. And then now, instead of just displaying the text here, I'm going to draw out the arrow. And so I'm going to create 2 more vectors. The first one, I'm going to call it point 0. And then that's going to be a point at the center of each of these cells. And then I'm going to create another point which will show the x and y components of the arrow. And then I'm going to create a line with that. So point pt of 0 is create vector of I times size, j times size. Oh, and I also need to put in an offset here with size divided by 2. And then let pt1, this will be equals to arrows of I and j. And because this vector has x and y components, right? We want the x component, and then we want the y component. And you need to not forget to also multiply it by a radius, right? Why? Because I'll show you why. So if I were to just draw a line from pt of 0 point x, pt of 0 point y. So this is the x and y location of pt of 0, and then we want pt1 point x and then pt1 point y. And then let's look at this. Oh, whoa. What did I do wrong? So we also need to add pt0 here as well, because right now pt1 dot x, it's all between -1 and 1. So we'll put pt0 point y plus. All right, you can see here, because these points, because the radius is 1, you can't actually see the direction of the arrow. So let's declare the radius and do maybe size divided by 2. And then we will multiply r times here. I did something wrong. What I did wrong here is I forgot to close parentheses here. Okay, let's try this. All right. Okay, so now what if we also draw an ellipse at pt1 of x and pt1 of y? Then let's set the size to maybe 5. So you can see the end of the arrow. Oh, and yes, I forget the same thing, which is pt0 point x plus pt0 point y plus. All right, but we don't want to stop here. We were using the 2D noise map, which generate this 2D map, but I want to introduce another variable called x of, or the third argument, and you'll see what this does. So let's do x of here, start it with 0. And then where we increment the x offset, we are also going to increment the z offset. So, whoa, okay. So you can't actually use the same increment for the z off, or you can, but it would go kind of crazy and chaotic as you saw. So let's just make it maybe 0.0001. Let's try this. Okay, maybe that's too slow. All right, so with this, right, the movement of the particles that we put onto this grid will be, more dynamic. Now that we have this, let's start making a particle object. I'm going to create a new file called particle.js, and then go to index.html file. Underneath here, copy and paste this line of code, and then put in your new file, the name of your new file. So for me, it's particle.js, and this is the way that you tell the computer to integrate this new file into your program. Now let's go back to this blank sketch. First, to create a class of particles, you write the word class and then you name it particle. In the constructor function, I'm going to give it 2 parameters, x and y, for the location of a particle object. But instead of what we usually do, which is set a variable this.x equals to x, this.y equals to y, I'm going to set a new variable called this.position, and I'm going to create a vector, right? A vector is an object with 2 values, right? And the 2 values that I'm going to give it is the x and y location that I will be giving it when I create a particle object. All right, so right now what we're doing is that we're going to create a simple physics engine. Apart from the position variable, we need 2 more things. One is velocity, and velocity is essentially speed and direction, right? Speed and direction of how the particle is going to move. And we're going to set a vector for this as well. But I'm going to set the values, the initial values, to be 0, 0. So it's not going to be moving when we first create a particle object. Then the third thing is an acceleration. Same thing, we're going to give it an initial value of 0. And these three components, position, velocity, and acceleration, is the main basic components of a movement of an object. And it's part of a basic physics engine. So when you add velocity, which is magnitude and direction, to position, you move from one point to the next point. Whereas acceleration is the change of velocity, or it's the change of the speed and the direction of the movement of an object. So imagine an apple that is falling from the sky, or from an apple tree. It is being pulled down by gravity, and gravity is essentially acceleration, a downward acceleration of a magnitude of 9.8 meters per second square. You don't need to remember any of that. All I'm trying to say is that an apple is falling downward at a constant acceleration, but the speed is increasing as it comes down, meaning that it's traveling at a greater speed every second. And we can represent that concept using, I'm going to create another method called update. Velocity is a change in acceleration, and that change is done by adding the acceleration vector to the velocity vector. And add is a method within the vector class. So you can add two vectors together. And then position is a change in velocity, and you can do the same thing. Just like that. Okay, and then let's do the third method called display, and we're gonna draw an ellipse. So a particle will be an ellipse. And so it will be at this dot position. And now because it is a vector, which is an object, so we need to get the x component. So this position, this dot position dot x, and then this dot position dot y, and then we want to give it a radius. So let's do 10, 10. So once we have this, let's just try to draw it out in our sketch. Let's create a particle called P, and P is going to be a new particle object, and then we're going to give it x and y position at random. So random between 0 and width, and random between 0 and height. All right, and then we're going to put it at the very end here, p dot display. So let's just first display it. It's up here. It's kind of hard to see, so let's go back to particle. What if we make it red? Oh wow, okay. And then now we need to fill the rest with white. All right, so that's our particle. And we also want to call the update function, right? But it's not moving. It's not moving because right now the velocity and the acceleration initial values are set at 0. So let me just show you. So what if it's moved to the right by 1? Okay, right? So is that what you expected? So this is moving down. But let's see, if we were to change the acceleration instead of the velocity by 1 unit. Can you see that? At every second, it speeds up, right? But the acceleration is constant at 1, 0. Same thing, just like gravity, if it's being pulled down, right? The acceleration or the gravity is constant, but the movement speeds up. So we don't want to actually set a constant velocity or a constant acceleration. What we're going to do is that we're going to use the direction of the force vectors, right? So now going back to the grid of force vectors that we made, we're going to use that as acceleration that push around the particles on the grid. So now I'm going to create a method called apply force. And we're going to apply what? A force, right? A force to our acceleration vector. So we just do add and then force. So I'm actually using many of the same terms in the same setup as Daniel Schiffman from the Coding Train channel, and he has done an amazing job on creating a bunch of tutorials on these type of physics engines, so please check those out. What we need next is that we need to figure out what is the force that we want to apply to the particle, and how do we know that? So first, let's create a new method called direction, and we're going to put a parameter here as a flow field, and basically the argument that we're going to put in the sketch file is going to be our arrows to the array. So how this direction method is going to work is that first we want to figure out which cell is the particle object is on. So we're going to create a variable called I, and then I is going to be equals to this dot position dot x divided by size. This will give us the column that it's on, and then for j, same thing, but for y. And then we're going to use this to get the information from the arrows to the array. So we're going to create a vector, right? A vector force, and inside here, what we need is that we need to get information from the 2D array that we're going to pass in as argument here. And we're going to get it from the location of I and j. And then we need from the x component, and then we need from the y component. And then once we have the force here, we're going to call this method inside this class. And then we can call this by just put this dot apply force. Then we just want to put in this force as an argument here. All right, so let's go back to sketch.js and then let's try it. So let's do p.direction, and inside here we need to put in arrows. Oops. What if we just print I and j first? Okay. So you can see that it's a float, and an index value cannot be a float. So what we need is that we need to put the word floor here. This will give us the closest integer. All right. Seems to kind of work, but then it also gives us an error. This error, I know why. Okay, so basically, as you can see that it gives us an error when the particle moves off the screen, right? And that's because now I and j is a negative number, and you cannot pull out, there's no values inside the index of negative numbers. So what we need is that we need to constrain the value. So I equals to constrain of I between 0 and columns minus 1, j equals to constrain of j, comma 0 to rows minus 1. This should work. All right. Okay. One thing that we need to fix first and foremost is that, as you can see here, it's moving really fast. So I'll show you something. So remember what we said about an apple falling? An acceleration or gravity is constant, right? So let's print p.acceleration. Actually print. Dot x, and then p.acceleration dot y. And as you can see from the values here, the acceleration values are not constant, and that's why it's moving so fast, because not only that velocity is changing, the acceleration is also changing, right? So what we need to do is that we need to go back to particle.js. Inside the update function, what you want to do is that you want to multiply the acceleration value, and you can use this method called mult by 0 every time update is called. So in every loop, right? So let's just try and run this. So you can see that acceleration is multiplied every single time. to 0 before it gets applied again. And this way the acceleration value remains constant. And then the next thing that we need to fix is that once the particle goes off screen, we want it to come back, right? So let's write a new method, and I'm gonna call it check edges. And we're gonna write 4 conditional statements. So if this dot position dot x is more than the width, then set it to 0. Let's copy and paste this 4 times, 3 times. So if it's less than 0, then set it to width. Same thing for the y direction, right? So if it's more than height, set it to 0, and if it is less than 0, then let's set it to height. And then let's call it in sketch.js here p.check edges. Let's try this. Ooh. Oh, okay, dot x, dot y, and dot y. All right, it's still moving really fast. So that's because the velocity is also changing very quickly. So another thing that we need to do is that we also want to limit how fast the velocity can be. So we're going to use a function called limit, and then let's try to limit it to 2. Let's try this. All right, that's better, right? Okay, so now we want a bunch of particles, right? Not just one. So let's create an array of particles. So let's do particles, set it as an array, and then let's create another variable called num. How about 100 arrays? And instead of just creating just one particle object, we're going to use a for loop. We're going to loop it through num, and we're going to populate the particles array with new particle objects at random width and random height. That is fine. And then we're going to copy this for loop here. I don't need to print this out anymore. And then inside here, what we need to do is that we need to call all of these methods. And instead of just writing p dot, we need particles of I, right, for all of them. All right. So it's not as beautiful as the flow field maps that you probably have seen, but let me just beautify it a little bit and then you can go further with it. So I'm going to go back to my particle.js file. Here in display, I am going to set the size to, let's do, how about 2? And I'm going to give it a color black. And I'm actually going to draw it at a transparency of 20. So it's gonna build up, right? It's not gonna be super black initially. And then I'm gonna put in no stroke. And then inside the sketch function here, I'm going to move the background to the setup function. And I'm gonna make it 255. So this way, background is not redrawing every single time, and I'm not going to draw the arrows or the rectangles anymore. So let's comment all of these out. Let's click run. Oh, here, we do not want to comment this part out. All right, that's quite beautiful. Right now I'm just drawing ellipses, right? You can try to draw a bunch of vertices and then connect them or make it a line, change the colors, change different things, and try to make beautiful flow fields more beautiful than this one. So hope this sparks more and more ideas for you. So please give it a try.